There are 8 basic types of variables in Visual Basic, and using the right one for the right application will help make your program function better, and it'll make it more clear to the people who are reading it. So the most common variable types are single and double precision numbers. Single precision number goes from minus e to the 38, so that's a large negative number, to minus e to the minus 45, so that's a negative number that's near zero, and it's or it's in the range of e to the minus 45 to e to the 38. Okay, so it's a large number that's negative to a small number that's negative, or a small number that's positive to a large number that's positive. So double precision is the same thing, except it's much larger in a negative way, or much closer to zero. And this is accomplished by including many more significant digits, about twice as many for double precision. So those are how numbers are represented as regular numbers. Integers that are variable types used for counting. That's a type that will have this range, and a long integer has this range. If you've got to count to some very big numbers, that might be appropriate. Dates date is a variable type, and so if you have dates for when samples were made, that kind of thing, that you want to manipulate, then using this type of variable is going to be a helpful thing. A string is a variable that it consists of alphanumeric characters, letters. So you can have variables that are words or even sentences that are of type string. And Boolean, that variable type is either true or false. And this type variant can be any of the above. So what Visual Basic does is, if you don't declare what the variable type is, then it assumes by default that it's a variant. And so if you don't really know about variable types and don't use them, you can get your program to run because they're declared as variants. But it won't be very clear, and there can be problems if you always use that default. So here's how it works. You declare the variable type at the beginning of the program, and the syntax is to use the word dim, and then this is the variable name, and then you say what the variable type is. So it's a double precision variable, a single precision variable for time. The well name is a string of 20 characters, and then these this counter variables I, j, and k are all integers. So the syntax, if you write it like this, is one variable per line. If you want to have multiple variables per line, then you can write it using this syntax. So this is just for variables that are used within a particular function or subroutine. If you want to pass variables into a function and give them a variable type, or if you want the value determined by the function itself to have a variable type, then you do it like this. So this would be the header for the function. This is lifted from the air function that you wrote earlier, and we have x as a variable that's getting passed in, and we give it the type here, and then the result of the air function is given a type here. So the number that is passed back into the program when the header is written like this will be double precision. And so you can have a function of many arguments that have many different types, and here's an example where there's some single and double precision, some integers, and a Boolean. Booleans are used to decide whether you should do something. That's one application. So here's a Boolean called OK to stop. And presumably within this function, if OK to stop is true, then it would stop. Okay, subroutines also can have variables that are typed as they get passed in, like this. So before we get to arrays, let me say something about the scope of variables. Variables that are defined like this within a function will have what's called a local scope. Those variables will only be present when this function is called. So when the function gets executed, Visual Basic will make these variables and it'll use them while the function is being executed. As soon as the function is done, these variables are done. So they're just local variables. They have a local scope to the function in which they're declared. Variables that have a global scope will be accessible by any function while the program is being run. And these variables are declared using syntax that's similar to this, but they have to be declared at the beginning of the program. So I would urge you, for the most part, to use local variables. Global variables are described in the notes, and you can look at the notes for more detail. So in addition to the variable types that we've just seen, we can also declare arrays. And arrays are strings of, well, arrays are like an assembly of multiple scalars. So here's a one-dimensional array that consists of these 5 numbers. This is also called a vector. A one-dimensional array is called a vector, and so this is a collection of these 5 numbers. And we write this one-dimensional array. It has a name, and then in these square brackets it has a number. And this number is the index to this location, and so on. So this index tells you what location in the array to use. And basically then you go there and get the number that's stored at that location. So the index is set up. This is 1, 2, 3, 4, and 5. So the array with the index of 4 will return the number 6 because it's at that location. So this is a one-dimensional array. We could also have a two-dimensional array, in which case a two-dimensional array you could visualize as very much like a page on a worksheet. It would have columns and rows, and it would have 2 sets of indices, one for columns and one for rows. So to declare arrays, you use a syntax like this: dim, and then this is the name of the array. And so this is very similar to declaring a scalar, except we have parentheses here and we put a number. And that number is the size of the array. So there'll be 100 values in this array. This syntax for declaring the arrays allows the array to go to from 1 to 100. And in both these cases, these are one-dimensional arrays that, this one will go from 0 to 100 by default, the index. And then a two-dimensional array is declared like this. So this has 100 columns and 200 rows. And then you follow the variable name with this syntax, which is the type of variables. So in this case, we have this array that has 100 values that are single precision. So that's how that would be set up. So in addition to variable types, it's also important to know the functions that are built into Excel. We can write our own functions for virtually anything that we want to do, but there are built-in functions, and I would recommend that you become familiar with them so you know how they work and how to implement them. This is a list of the built-in functions, and this is the absolute value, arctangent, cosine, the exponential, the fix function. This is, I think this just cuts off all the values to the right of the decimal point. This gives the integer, the log, a random number, the sign of the number. This is the sign as in positive or negative. This is the sign as in the trig function. And this guy here is square root and tangent. And then in addition to that, there's some other ones like the hyperbolic cosine, things like that are built in, and those are described in the math function. If you go to VBA help, you can find more information on all of these functions. If you search for math function, for example, all of these will come up. So you should take a look and see, look at the details. There are some peculiarities here that you should know about. For example, see that function there, log. If you use that in Visual Basic, you'll get the natural log of whatever parameter you use. Okay? But if you use that in the Excel worksheet, same function, you get the base 10 log. So, on one hand, you ask Bill Gates, what the heck are you thinking? But on the other hand, this is the way it's set up, and the natural log is actually a more natural function to use for mathematics, and so maybe they just wanted to include it as the log function in the programming language. I'm not really quite sure, but what it means is that it's important to know the details of how these particular functions work. Another peculiar one is SQR. So that is the square root function. In other programming languages, SQRT is used for square root. In this case, it's SQR. It seems that that's more like square than square root, but nevertheless, this is how the Visual Basic language is set up. So take a look at those. Most of them are self-explanatory, but it is good to look at the reference and look at the help and see how they're described.